How many of you know the famous Nigerian Whot game? If you're a Nigerian, then you are already familiar with this game. If not, well, by the end of this video, you will not only know how to play this game, but you also code up a simple implementation of this famous game. This game is loved and played by young and old folks alike in Nigeria, and our goal in this video is to build an abstraction of this game. You might ask yourself, what is the purpose of doing that? Well, what better way to learn to code than to build something? It might seem trivial, but at the end of this video, you will have learned a lot about how to solve challenging issues when coding and how to provide code abstractions to real-world problems. So without much talking, let's dive into what we have for today. But before we do that, I need to address something. Many of you watching my videos are not subscribed to the channel yet. Do you care to explain the reason why? If you like the idea behind today's video, then absolutely smash the like button. It keeps me motivated to ship out videos like this, and it ensures that other users can find it. Ensure you subscribe to the channel and turn on the bell notification to get access to all of our videos in the future as they drop. Let's start by going over the basics of the game first. A typical Whot game consists of 55 cards, but it is normally played with 50, and as such, our implementation will only contain 50 cards. Each card has a specific value and a corresponding shape. There are 5 shapes in a game: star, cross, circle, triangle, and square. And with this information, I will create a type card_type, which will be a union type of the shapes triangle, circle, square, star, and cross. Now we have declared these union types. The next thing we need to do is to create a class that represents an actual card. I will define and export a class card from the file. Inside this file, I will add a private_type property, which is of card_type, and _value property, which is a number. I will add a constructor function that accepts a type argument, which is a card type, and a value property, which is a number. And inside the constructor function, I will set this.type to be equal to the type argument, and this.value will be equal to the value argument. I will add a getter to retrieve the card value first, and then I will also add another getter to retrieve the card type. Let's try to create a card so you can get a better idea of where we are heading. For that, I will create a new variable, new card, which stores the result of instantiating the card class with circle as the shape and 14 as the value. Then I will console log the card, and you can see the newly created card in the terminal. Now we are done with that. The next thing we need to figure out is how to handle players. For that, I will create a new class, player, which I will also export from this file. And inside this class, I will add an ID property, which is a number, and an _cards property, which is an array of cards. Then I'll add the constructor function, which accepts an array of cards. And inside this function, I will set the _cards property to be equal to the cards argument. And then I will create a random ID to serve as the ID for the player. I will add the getter function that fetches and returns the _cards property, and I will also add a setter function that allows us to update the cards of a player. Now we are done with implementing the player class. We need to work on the game logic itself. We are now getting to the interesting part of our code. First, I will create a class game, and inside this class, I will add a read-only property max_num_players, which will be equal to 6. This is responsible for controlling the amount of users who can play the game. And from what we have here, the max number of players that can play a game is 6 players. Now, each Whot game have what is termed as market. This is usually a stack of cards reserved for players to draw a card from if they cannot provide a card that qualifies as a valid play. We will come to what a valid play is shortly, but let's continue with what the market is. There are also certain instances when a player will be required to draw a card or multiple cards from the market, and we'll also come to that. For now, I will just add a market property, which is an array of cards. I will also add a deck property, which is just a temporary storage for cards before we start a game. Once a game is started, we will no longer use this deck property. I want the game to control how the players act, so I will declare a players property on the game class, which is an array of players. We need to keep track of the cards that have been played, and as such, I will add a played cards property on the class to handle this. Then we need to keep track of who the next player is. You could also track the current player, but I decided to use this approach for God knows why. And I will add a next player property, which is a number. Then I will add a cards property, which is an object that keeps track of the cards in the game. Each key will correspond to a value shape in the game, and the value for that key will be an array of all possible numbers for that shape. I will add an _is game over property, which is a boolean. It is responsible for telling us when the game is over and I will add a getter function is game over to fetch this property. I will add a helper function getPlayer that fetches and returns a player based on the index of user in the player's property on the game class. This index will be passed in as an argument to this function, and the index is not expected to be greater than the length of the player's array. Then we will fetch and return the user based on their index. I will add 3 more helper functions, starting with the getDeck method, which returns the deck. Then I will add a getMarket method, which fetches and returns the market. And finally, I will add a getPlayedGames function, which fetches and returns the played cards in the game. I will add a helper method shuffle, which accepts an array of cards as its argument. The job of this method is to simply shuffle the cards passed to it as arguments. Then I will add another method, createDeck, which is responsible for creating a new deck. Inside this method, I will create an array of card types from the keys on this .card. Then I will create a variable card ARR, which is an array of cards. It's going to be an empty array for now. Then I will loop through the card type array, and for each card type, I will retrieve the value of the card type from this .cards using the card name variable, which I am going to store in the cards array variable. Then I will in turn loop through each value from this .cards card name, and for each value, I will create a new card using the card name as the card type, and then the value as the value of that card. Then I will push the card into the cards ARR, and after all that looping, that is if we don't loop ourselves to heaven, I will shuffle the cards array and then assign it to the deck. Then I'll return this .deck from the function. Let's pause first and test this out by creating a new game and calling the createDeck method on the game. I will store the result in a variable deck. Then I will console log the deck, which you can see in the console. And let me expand it a bit so it's more clearer. Now, we need to have players that can actually play the game, and for that, I will add a new method, createPlayers, which accepts 2 arguments, amount, which is a number, and initial card number, which is also a number. The amount will represent the amount of players to be created, while the initial card number is the number of cards each player will be dealt with when the game starts. If the amount is greater than the max number of players, I'm going to throw an error, invalid number of players. Then I will add a loop that will run until I is less than the amount, and for each iteration of the loop, I will use the player constructor to create a new player and then assign him the initial card number by splicing it from the deck. Then I will push the newly created player into this .players array, increment I, then I'm going to return an object with a player's property which is equal to this .players from this function after we exit out of that loop. I'm going to add a pick method that will return the last card that was added to the played cards array without removing it from the array. I will add a method getCard, and this method is going to simulate the process of a user selecting a card. Since we are interested in the game logic for now, I will need to simulate this using this function getCard. The function accepts 3 arguments: the player who wants to select a card, the type argument which is of card type, and a value argument which is a number. Inside the function, I will loop through all the cards of the player until we find a card whose type matches the type argument or whose value matches the value argument. Then we will return the index of that card from the function. We are all but set now, but we need to implement the start function that starts up the game. And for that, I will add a start method which accepts 2 arguments: player number, which is a number, and initial card number, which is also a number. Remember, a player number controls the total amount of players in the game, while the initial card number controls the amount of cards dealt to each player at the start of the game. Inside this function, I will call this .createDeck to create a new deck, and then I will call this .createPlayers to also create the players with the player number and the initial card number as argument to this .createPlayers. I will set this .market to be equal to this .deck, and then this .deck is going to be an empty array. This moves all the cards from the deck to the market, which is in principle what happens in a Whot game after the players have been dealt cards. Then we are going to push a new card into the played cards array from the market, and then the next player is going to be the first player. And then I'm going to return the market, the deck, and the played cards array from this function using an object. If I test this out by calling game.start and storing the result in a variable result which I console log, you will observe that the market now has cards inside, deck is empty, and the played cards have only one card inside. The next thing we need to do is to work on the play logic. That is the logic that will allow players to play a card. And for that, I'm going to add a new method on the game class. This method will be named play, and it will allow users to play their turn. Remember, we have started the game, and in the process we have created players, dealt them cards, so they need to play the cards they've been dealt. The play method will accept an optional argument, card number, which is a number. It is the index of the card that needs to be played in case we decide to externalize the process of card selection. But you should know that this process is going to be implemented inside this method because we are simulating the players. Inside the function, I will check the game is already over, and if that is the case, I'm going to console log game over and return from the function, effectively ending it prematurely because you cannot continue to play when the game is over. Next, I will check if the market contains no cards. That is, all cards have been drawn from the market by the players. We will set this dot underscore is game over to true to signify that we have gotten to the end of the game, and then I will return from the function prematurely. Next, I will retrieve the current players from this dot players using the next player property on the class. Then I will also retrieve the last card that was added to the played cards array by calling this dot pick. Remember, the pick method fetches and returns the last card that was played without removing it from the played cards array. The last played card is going to be stored in a variable last game. I will also retrieve the cards of the current player, which I'm going to store in a variable player cards, which I incorrectly named played cards. Ignore this bulb for now and just flow with me. I will try to get the index of the card that should be played next using a conditioner. First, I will create a variable card whose value is going to be that conditioner. I will check if the card number argument is passed to the function, and if that is the case, the card variable will be equal to the card number. If it is not passed to the function, then we will call this dot get card with the player as the first argument. Then the type of the last game will become the second argument, and the value of the last game will become the third argument. Next, I will use the card variable to retrieve a matching card from the player cards, and I will store the card returned inside a variable played card. This is not to be confused with the played cards array. I will check if the type of the last game matches the type of the played card, or the value of the last game matches the value of the played card, or the value of the last game is 1. Why all of these checks? This is because in the game, for you to be able to play a card, its value or type has to match the value or type of the last game that was played, or the value of the last game has to be 1, because you can play any card of any value or any type as long as the value of the last card that was played is 1. If that is not the case, that is, there is no match for the played cards and the last game, then I will remove one card from the market and push it into the played cards. Remember, the played cards store the cards of the current player, because in the Whot game, if you do not have a valid card to play, you have to draw one game from the market, and then we are going to update the next player property so the game moves on to the next player, and then I'm going to return an object with a market property which is equal to this dot market, and played cards property which is equal to this dot played cards. If the card is a valid card, then we need to handle that. First, we will push the card into the played cards array and then advance the game to the next player. Then I will create another variable filtered, which is an array of cards. Then I will loop through the player cards and push all cards that are not the played card into this filtered array. And now we need to handle special conditions in the game. There are certain cards a player will play that needs to be processed quite differently from others. Any card with the value 14, 8, 1, and 2 are special cards and they need to be treated differently. So let's start with 14. Anytime a user plays a card of value 14, all other players will need to go to the market, which means they will need to draw a card from the market, and for that we need to add an if statement that checks if the value of the played card is equal to 14, and if that is so, I will console log go market. Then for each player in the game that is not the current user, we will remove a card from the market and add it to their stack of cards. Normally, the current player who played the go J, as it is commonly called, needs to play another card of the same type after the go J card, or he will also draw a card from the market himself. But in all honesty, I forgot about this part while coding up this implementation. But I just want you to know that this is also a part of the rule in the game. Next, we need to handle the value 1 using another if statement. If the value of the played card is 1, then I will console log 1 and anything. We want to ensure that the game does not progress to the next user. And that is, the current user will also be the user that is going to play the next turn. Forgive me for using user here, but you know what I mean. User and players, they all refer to the same thing. That is, if you play a card with a value 1, you should also be able to play any other card of any other value or any other type. We are done with handling the special value 1. We need to handle the value 8, and this is known as a suspension. Whenever a card of this value is played, the next player will miss his or her turn, and the game will move on to the other player. And for that, I will add an if statement that checks the value of the card if it's equal to 8. And if that is so, I will console log suspension. And after that, I'm going to ensure that the game skips that player and moves on to the next. And finally, let's handle the special value 2. Whenever card of this value is played, the next player will have to draw 2 cards from the market and they will skip their turn. I will add an if statement to check the value of the played card. And if it is 2, then I will console log pick 2 and add 2 games to the cards of the next player. I will allow you to add the skipping logic because I already did that, but in all honesty, I forgot to skip the player's turn. I will check if the current player only has 1 card left, and then I will console log last card, because this is one of the rules of the game. You must notify other players that you only have 1 card left. Next, I will check if the current player has played all of their cards, and if that is the case, the game will have to end because we have found a winner. And I will set this market to be an empty array, this underscore game over to be set to true, and then I will console log who the winner is, and then I will return the market and the played cards from the play function. Now let's test this out by adding a while loop that will run until game.isOver is true, and inside this loop I will call game.play. Now let's test this out by adding a while loop that will run until game.isGameOver is true, and inside this loop I will call game.play. Then I will console log the card that was played, and finally I will console log the length of the market. You can see the result in the terminal. Now, isn't that absolutely amazing? If you found this video useful, then absolutely smash the like button. Ensure you subscribe to our channel to get access to all of our videos in the future as they drop, and I'm going to see you in the next one.